It brightens our lives. It energizes us. It enhances our productivity. It brings us many joys. Yes, it is electricity, the most utilized source of energy since its discovery. A boon to mankind. In today's world, it is difficult to visualize our existence without it. This has led to significant rise in the electrical installations and related services. It has also increased the possibility of electrical hazards resulting in fatalities. Fire in electrical installations may be broadly caused by overcurrents, harmonics, inadequate design for earthing, electric arcs in cables and loose connections, failure of protection device or wrong selection of protection device, wrong selection of cables or wires, use of outlived or damaged equipment, over voltage, improper or no verification and testing of installations. Let us understand the effect of electric current on the human body. The severity of the shock a person receives depends upon amount of current flowing through the body, duration of current flow, path of the current through the body, length of time the body is in the circuit, touch, voltage and frequency, degree of moisture of the skin, surface area of contact, etc. Good quality electrical installations shall ensure prevention from accidents such as electrocution, fire, etc. and shall also offer trouble-free long life for the equipment connected. To ensure safety of persons and apparatus against electrical faults, it is necessary to follow the requirements for protection as mentioned by various Indian standards.
Electrical safety is important as thousands of people die every year in developing countries due to electrical accidents. Fire has destroyed property worth millions of dollars. As electrical energy strikes without warning, vigilance is a necessary prerequisite to avoid accident. Data reveals that 42% of fires in the buildings are due to electrical short circuits and thousands of deaths are caused due to electrical reasons. Majority of electrical accidents such as fire happen in low voltage systems. The main reason for electrical accidents are poor design and quality of electrical installations, maintenance, workmanship issues and old installations. Today, the world is propelled by technological innovations and technology is expanding and evolving at an unimaginable pace. The challenge before us individually as well as collectively is to draw up the best global practices and standards. The process of standardization extends to all the spheres of activity and every product to ensure high quality and all-encompassing uniformity. To ensure safety of persons and apparatus against electrical faults, it is necessary to follow the requirements for protection as mentioned by the various Indian standards. It is also the requirement of time that electrical engineers and technicians shall be familiar to the correct practices.
Bureau of Indian Standards, through its Electrotechnical Division Council (ETDC), is involved in the preparation of Indian standards and codes of practices in the field of electrical engineering. The Electrical Installations Sectional Committee (ETD-20) under ETDC is responsible for preparation of Indian standards for safety and other important matters like designing, erection and maintenance of electrical installations.
BIS is responsible for formulation of Indian standards in various areas of science and technology. These Indian standards are developed by relevant technical committees comprising of representatives of various stakeholder interests such as industry, consumer technologists, scientists, professionals, academicians, government policymakers, regulators, etc. Under the Electrotechnical Department of BIS, we have the Safety of Electrical Installations Technical Committee (ETD-20) responsible for standards for safety and related matters in designing, erection and maintenance of electrical installations from the point of view of safety. Till date, 64 Indian standards are published by the ETD20 Sectional Committee and 11 standards are presently under development. Also, a major project of revision of National Electrical Code of India has been undertaken and recently completed by the ETD20 Technical Committee, utilizing scientific knowledge and experience in areas relating to electrical installations in buildings.
The design, installation, verification and maintenance of electrical installations must comply with the Central Electricity Authority regulations. Any contraventions with the provisions of rules and regulations may attract penal action as per Section 146 of Electricity Act 2003. The National Electrical Code of India 2023 is a comprehensive electrical installations code prepared by BIS, providing guidelines for regulating the electrical installations practices across the country.
Safety of electrical installations, ETD20 Sectional Committee of BIS has formulated National Electric Code of India. The National Electric Code of India covers the following: standard good practices for selection of various items of electrical equipment forming part of electrical installation, recommendations concerning safety and quality of the wiring in the electrical installation of buildings or industrial structures, promoting compatibility between such recommendations and those concerning the equipment installed, general safety procedures and practices in electrical work, and additional precautions to be taken for use of electrical equipment for special environmental conditions like explosive and active atmosphere. Reference of NEC is mentioned in Central Electricity Authority safety regulations. The NEC contains guidelines for adoption by various stakeholders. Its provisions are expected to serve as a model for adoption in the interest of safety and economy and with the intent to keep our electrical installation practices at par with the best practices in the world.
The National Electrical Code of India 2023 contains 8 parts of 49 sections. Part 1. General and common aspects. Part 2. Electrical installations in standby generating stations and captive substations. Part 3. Requirements for special installations or locations. Part 4. Electrical installations in industrial buildings. Part 5. Outdoor installations. Part 6. Electrical installations in agricultural premises. Part 7. Electrical installations in hazardous area. Part 8. Solar photovoltaic power supply systems.
Part 1 largely covers general and common aspects of electrical installation, highlights the need to handle electrical works in accordance with relevant guidelines right from concept stage to completion and post-completion maintenance. In initial sections 1 to 8, scope of NEC, exclusions, definition of fundamental terms, guidelines in respect of preparation of drawings, diagrams, charts, etc., units of measurement, standard values, fundamental design principles, general characteristics is covered. Section 9, this is very important section which is closely associated with electricity and its human interface through wiring installation. This section highlights need of coordination between works of architect, civil construction, other building services from the perspective of requirements of electrical installation. Section 10 to 13 provide information about possible threats of leakage and overcurrents, voltage, thermal effects arising from electrical installation and protective measures to counter or mitigate them, taking references from newly published standards. Section 14 to 16 provides method of calculation of short circuit current, impedance and voltage drop, electrical aspects of building services and selection of equipment having conformity to standards, supply parameters, suitability with environmental conditions, prevention from harmful effects, etc. Section 17 is an important section aligned with IS 732. This section guides users to check various points enlisted therein. thus tests and procedures with model forms of reporting. This section includes a form of undertaking from the persons involved in design, construction and testing of electrical installation. Section 18 covers general requirements associated with earthing in electrical installation. Latest provisions from IS 3043 and IS 730 have been compiled in this section. Different earthing systems with diagrams are self-explanatory. Section 19 provides guidelines on lightning protection system, risk assessment for building and electrical installation. It highlights the need of coordination between architect and the system provider. Section 20 speaks about power quality, pinpoints the causes and its effects at user end and the supply system. Under the scenario for increasing use of systems and appliances having non-linear load, this section is very important. Section 21 covers aspects of energy efficient design, selection of equipment and the need of energy audit to optimize energy use. Concept of load energy profile, barycenter method or deciding distribution centers, setting up power monitoring devices from this section will be useful for the designer to achieve the goal of energy efficiency. The last section of the part 1, section 22, provides information about statutory provisions and obligations related to electrical safety, preventive and curative measures to be observed in design, construction and verification testing of electrical installation. It will provide guidelines for streamlining administrative controls to monitor safety procedures and practices during operation and maintenance. Overall, the information and guidelines provided here will be a path to reach the goal of electrical safety.
Part 1 has a dedicated chapter in lightning protection, since the damage caused by lightning strike can lead to destruction of household, office or industrial structures and even loss of lives.
Lightning is a natural phenomena and occurs due to sudden electrostatic discharge. It can be seen as massive spark in atmosphere between cloud and earth surface. Lightning looks fascinating to watch, but it is highly dangerous. It is dangerous because lightning carries tremendous amount of energy, which is not only damaging the structure itself but also its occupants, contents and other systems. We do not have control over lightning as we cannot stop or prevent lightning to happen. However, we can install lightning protection system which is safely divert the lightning current to the earth, thereby protecting the structure, lives and various other important systems. That's why lightning protection system of NEC is very important section which provides general principle to be followed for protection of structures against lightning. This lightning protection section provides overview of various effects of lightning, damages due to lightning and need of lightning protection based on risk assessment. This section of NEC draws reference from ISIC 62305, which is an Indian standard already in place for protection against lightning.
Part 2 of National Electric Code of India covers the requirement related to standby generating station and captive substation. This part is divided into two sections. Section 1 is on electrical installation of standby generating station. This section of the code provides guidelines in respect of electrical design, selection along with installation, testing, commissioning, maintenance and statutory compliances in respect of standby generating sets having individual capacity up to and including 2000 kVA. Section 2 is on electrical installation in captive substations. These guidelines given under this section are applicable to distribution transformer with individual capacity not exceeding 2.5 MVA and substation capacity up to 10 MVA and voltage level up to 33 kV.
Part 3 of the code covers the requirements of electrical installation in special locations, where safety measures in addition to recommendations of Part 1 is necessary. Special locations which are in common use are community halls and offices, example building open to public, office buildings, shopping and commercial centers, educational institutions, hotels, EV charging and electrical installation in multi-storied building. These are locations where the safety measures used in general part of the installation cannot be applied. For example, as a measure against electric shock from a fault, the recommended safety measure called as protective equipotential bonding and automatic disconnection of supply may not be applied. Sometimes other measures such as double insulation, supplementary bonding are mandatory in some of these locations. These are located in respective sections of Part 3. Hence, Part 3 need to be read in connection with Part 1. For example, Section 9 of Part 3 explains about medical locations, which is an area where patients are being treated. They are classified into Group 1 and Group 2 locations. In these locations, metallic objects or conductive fluids are bypassing the skin. As a result, chance of shock for the patient under treatment is much higher. So we need additional shock reduction measures. Medical locations are also oxygen-rich areas. Sometimes highly flammable materials are also present. As a result, Group 1 and Group 2 locations need special measures against ignition from fire as well. In these medical locations, compliance of the standard is ensured by verification of the installation. Example, Part 1, Section 17 explains verification of general electrical installation. Implementation of these safety measures are very much necessary, keeping in mind the number of accidents such as fire in medical locations and especially in hospitals. The NEC will be a good document for electrical inspectors and fire officers to check the compliance of safety measures in these locations.
This part comprehensively classifies the types of industrial buildings and the attention needed to the design of the electrical installations arising as a consequence. The micro and macro environments of the buildings, the type of industries based on nature of hazards these buildings may be subject to, including fire hazards, pollution grades, average power requirements and all other factors impacting the safety, quality, continuity and conservation are detailed in this part. The Part 4 is of high importance to the industry, particularly the design engineer, as he is guided in the selection of equipment, layout of the installations and the method of installations based upon these characteristics and criteria.
Part 5 of NAC of India deals with the installation erected outdoor. It is the most critical and complex part as it addresses potentially dangerous, hazardous situation as installation is for public or for many users. It comprises of three main sections: public lighting installations, temporary outdoor installation, permanent outdoor installation. First section is public lighting installation and scope covers requirements of public lighting installations to provide guidance to those concerned with the preparation of public lighting scheme, their installation and maintenance. It is also lays down recommendations on the quality and quantity of lighting to be provided. Section 2 is for temporary outdoor installation and scope covers the requirement for outdoor electrical installation erected for duration less than 6 months. This section provides information about general characteristics, classification of temporary installation, general and additional requirements, protection and safety, testing and commissioning. It emphasizes importance for power distribution and earthing. Section 3 is for outdoor installations of the permanent nature. Consideration is given to the expected loading, operating characteristics and cycle duty, operational transportation and storage conditions while designing and selection of equipment and components.
This Part 6 covers requirement for fixed installations in agriculture premises, excluding dwellings or similar locations situated in these premises. These part cover requirement for external influences like presence of water, foreign solid bodies, corrosive or polluting substances, flora and fauna, etc., which are common at these locations. Requirement for wiring system, cable, protection devices, switch gears, isolations and control gears inaccessible to livestock suitable to these locations are given in this part. Requirement for selection and erection of electrical equipment to suit the environmental conditions of these locations are also given. Requirement for additional protection of various circuits, residual current devices of different ratings are recommended. Requirement for earthing arrangement such as equipotential bonding, protective conductor and protective bonding conductors suitable in these corrosive environments are mentioned. Requirement for provision of alternative or backup supply in high density livestock areas for supply of food, water, air, lighting to livestock which are dependent on electrical supply. Requirements for selection and erection of luminaries considering the combustible material and dusty environments are given.
Part 7 of NEC is intended to provide guidelines for electrical installations and equipment in locations where hazardous atmosphere is likely to be present with a view of maximizing electrical safety. The scope of this part therefore includes installations in hazardous areas such as petroleum refineries, petrochemicals and chemical industries. The requirements laid down herein are in addition to those specified in Part 4 of NEC. It is recommended that plants and installations in which flammable materials are handled or stored be so designed that the degree and extent of hazardous areas are kept to a minimum. Similarly, consideration should be given to design and operation of process equipment to ensure that even when it is operating abnormally, the amount of flammable material released to the atmosphere is minimized in order to reduce the extent of hazardous area. To determine the type of electrical installation appropriate to a particular situation, the hazardous area have been divided into 3 zones, namely Zone 0, 1 and 2, according to the degree of probability of presence of hazardous atmosphere. In addition to the properties of flammable materials involved, many other factors such as risk points, temperature of the process liquid, concentration of vapor, its rate of release, ventilation of the area, etc., need to be considered for determining the degree and the extent of hazardous areas while applying the guidelines given in IS 5572, which is the Indian standard for classification of hazardous area. Equipment to be installed in hazardous area have to be certified by a recognized testing authority. Marking of equipment to be used in hazardous area shall conform to IS IEC 60079 Part 0. This part includes generalized statements and recommendations on matters on which there are diverse opinions. It is therefore important that sound engineering judgment should be exercised while applying these guidelines.
India has ambitious target of reducing greenhouse gas emission as part of the commitment of global warming. Renewable energy constitutes a major component, which is expected to increase from 18% today to 44% to achieve the target of 450 gigawatt by 2030. Solar power generation target has been kept as 100 gigawatt by this year. A comprehensive guide specific to solar PV installation suitable for Indian condition has been developed with the help of industry experts and included as a new part 8 of NEC. Solar installation has a lot of DC system in which general protective system adopted for AC system may not work directly. Special measures are necessary for fault protection and shock protective measures. This part covers essential requirements for solar PV installation, including module, string and array, inverter, controller and balance of system in one consolidated place, covering design, installation, safety and quality requirements of PV installations. It covers requirements of wiring, protection, surge protective device and earthing of rooftop and industrial structure and cover all aspects in rooftop category as well as in utility scale. Special cable requirements for DC side IS 17293 and for AC side like FRLSH cable are also provided. Guidance for design of the system with selection of components and their specific requirements have been included. While preparing this part, effort has been made to align the requirements as far as possible with corresponding IEC standard IEC 60364-7-712, updating it with Indian experience. As a result, some changes have been made to cater to the need, keeping in view the typical Indian environment condition prevailing and safety requirements required to be met as per IS 732. It is expected that following this guideline would help the solar industry maintain quality asset created for the long-term benefit of the country.
Common first aid measures for an electric shock victim. A person getting electric shock should be detached from the source of electric power immediately. The disconnecting switch or breaker should be identified and turned off. If the source of power or the connected device cannot be located, then the victim should be pulled off from the circuit by an insulated object such as a dry wood board, piece of non-metallic conduit, or a rubber electric cord. Closely monitor if the victim is conscious. Provide care until trained emergency response personnel arrive. Keep the victim warm and comfortable to avoid a psychological shock. In case the victim is unconscious, check for breathing for about 10 seconds. If the victim is breathing, place in the recovery position. Dial 102 for ambulance. Monitor and record breathing every 10 minutes or until the medical assistance arrives. If the victim is not breathing normally, dial 102 immediately and commence CPR. Indian standards are driving a transformation in the electricity sector of the country for enhanced safety, better performance, increased efficiency, and compatibility towards environmental issues. Safety and efficiency can also be ensured by carrying out stringent and timely verification of the electrical installations and appliances as provided in the NEC 2023. Its provisions serve as a guideline to keep electrical installation practices in the country at par with the best in the world. NEC 2023, driving a transformation for the nation.